Hey everyone, today we are going to solve the Daily LeetCode challenge of 6 January 2024 and the problem statement is maximum profit in job scheduling. So let's first understand the problem statement. So according to the problem statement, we have been given 3 arrays. The first one represents the start time of a job. The second one represents the end time of a job. And the third one represents what is the profit that we are going to gain after completing this job. So say for example, if this is my job 1, then it will start at 1 unit of time and it will end at 3 unit of time. And after completing this job, we are going to get a profit of 50. And if this is our job 2, then it will start at 2 unit of time and it will end at 4 unit of time. And we are going to get a profit of 10 after completing this. Similarly, this is our job 3, which will be starting at 3 unit of time and it will end at 5 unit of time. And we'll be getting a profit of 40 after completing it. Similarly, this is our job 4 that will start at 3 unit of time and at 6 unit of time, and we will be getting a profit of 70 after completing this. Now, what are we expected to do in this problem? So we have to find what is the max profit that we can earn after doing these jobs. Now, we have to complete this job based on some condition, and that condition is that we can't do 2 or more jobs at the same time. So it means that we can't have any overlapping jobs. So it means that if job 1 is starting at, say, for example, 1 unit of time and job 2 is also starting at 1 unit of time, then either we have to do job 1 or we have to do job 2. We can't do both of them at the same time. Okay. Now let's see what could be the maximum profit for this example. So here I have drawn a number line and we are going to represent these jobs on the number line. Okay. So first, can we take this job 1? Yes. So let's say that I have started job 1, and if I start job 1, it's going to finish at time equal to 3. So this is job 1 and it's going to finish at time equal to 3. So if I'm going to do job 1, what is the profit that I'm going to get? I'm going to get a profit of 50. Okay. Now, can I do job 2? The answer is no. Why? Because job 2 will be starting at time equal to 2 unit, right? And we can see that at 2 unit of time, we are already doing job 1. So we can't do job 1 and job 2 at the same time. So I'll move to job 3. Now we'll see, can we do job 3? So the answer is yes. Why? Because it is starting at time equal to 3 unit, right? And by the 3 unit of time, we don't have any job because we have already completed our job 1. So what we'll do is we'll start this job 3 and it will be starting at time equal to 3 and it will be ending at time equal to 5 unit. So from 3, we'll start job 3 and it will be ending at 5 unit of time. So on doing job 3, what is the profit which we will get? We'll get a profit of 40. Now, can we do this job 4? The answer is no. Why? Because job 4 will be starting at 3 unit of time. And at 3 unit of time, we have already started doing job 3. So we can't do job 3 and 4 simultaneously. That's the reason why we won't be taking job 4. So in one iteration, we are doing job 1 plus job 3. And what is the profit which we are getting? It's 50 plus 40, which is 90. Now, let's see that if we are taking job 1. Now, let's say if we have taken job 1, so it's going to start from 1 unit of time and is going to end at 3 unit of time. So on doing job 1, we are getting a profit of 50. Now, can we take this job 2? No. Why? Because at time equal to 2 unit, already we are processing job 1. Now, since in the previous possibility, we have already explored this job 3. So now we'll be exploring job 4. So can we start job 4? Yeah, because at time equal to 3, we are not doing any jobs. So we will start job 4 and it will end at 6 unit of time. So from time equal to 3, job 4 will start and it will end at time equal to 6. So on doing job 4, we will be getting a profit of 70. Now, we don't have any more jobs left, so we are done with this possibility. So on doing job 1 and job 4 together, what is the profit which we will get? It's nothing but 50 plus 70, which is 120. Now, let's explore the last possibility. Now, what if we are not going to take job 1 and we are going to take job 2? So job 2 is going to start from 2 unit of time. Job 2 is going to start from 2 unit of time and it will be ending at 4 unit of time. So here will be our job 2. So this is job 2 and on doing job 2, we'll be getting a profit of 10. Now, can we do this job 3? No. Reason being job 3 will be starting at time equal to 3. and at time equal to 3, we are already doing job 2. Now, can we do this job 4? The answer is no, because it's also starting at time equal to 3, and at time equal to 3, we are processing our job 2. Now we have exhausted the array, so we are not left with any more jobs. So in this possibility, we are only doing job 2, so our profit will be 10. Now, since we are asked to find the max profit, so we'll be finding the max of 10, 120, and 90. So the max of these three is 120, and this is our answer. It means we are going to do job 1 and job 4 together to get a profit of 120. Now, what would be our approach? So as you can see that for each of the jobs, we are having two options. What are those two options? Either I'm going to do this job or I'm not going to do this job. Similarly, either I'm going to do this job or I'm not going to do this job. And either I'm going to do this job and I'm not going to do this job, and so on. So whenever we have options, we make use of recursion. So in this recursive approach, we are going to follow the take and the not take approach. It means either we are going to take a job or we are not going to take a job. So how are we going to solve this? So first of all, we'll start on by placing all these three vectors together at one place. So it means we'll create a jobs vector, which will be a 2D vector, and it is going to store all the jobs in it. It means that it would be something like this. So this is my job 1. So it will have its start time here, it will have its end time over here, and it will have its profit over here. Similarly, for job 2, it will store its start time, end time, and profit. And for job 3, it will have its start time, end time, and profit, and so on for rest of the jobs. Now, once we have created a 2D vector to store the start time, end time, and the profit of each of the job, what are we going to do is we are going to sort this jobs array. Now, I'll be explaining the reason later. Now, let's see first that if we are present at any job, say for example, if I'm present at job 1, so I'm having two possibilities. Let's say if I'm at current index, so I'm having two possibilities. What are those two possibilities? First, either I'm going to take this job or I'm not going to take this job, right? Either I'll take or I'll not take. Now, if I take this job, so I'll get a profit. I'll get a profit of this current index, right? I'll get a profit, so I'll add a profit. And where will I move? I'll move to the next index, right? Now, if I won't take this job, so will I get any profit? No. So I'll simply add 0 and I'll move to the next index. Now, what is this next index? Okay, say for example, if I have a job J1 and if I have a job J2 and if I have a job J3. Okay, now say for example, the start time of my job J1 is 1 and its end time is 3. And the start time of my job J2 is 2 and its end time is 4. And the start time of job J3 is 3 and its end time is 5. Okay, now if I am taking this job, means if I am doing this job J1, then after doing this job J1, which is the job to which I'll be moving? Will I move to job J2 or will I move to job J3? The answer is I'll move to job J3 and I won't move to job J2. Why? Because see, my job J1 is ending at 3 unit of time and my job J2 is starting at 2 unit of time. So is it possible to start J2? The answer is no, because from 1, 2, and 3 unit of time, in this time interval, I am already processing my J1. So I cannot start J2 in middle of that, because the condition is that we can't do 2 or more jobs at the same time. So we'll simply move to J3 because it is starting at 3, time equal to 3. By that time, we are already finished with our J1. So we can start that. So what will our next index be? Our next index would be great index of the job. It would be the index of the job for which the start time would be greater than equal to the end time of my previous job, which means for which the end time of the current job. Okay, now the question is, how are we going to find the start time? So for finding this start time, we are going to sort this start time array and we are going to use the lower bound. Now what this lower bound does is it gives us the just next greater value in the array. And since it makes use of binary search in the behind the scene, so for that reason we are going to sort this start time. So now let's quickly code this problem. So we'll start by creating a 2D vector and we'll name it as jobs. And now we have to populate this job. So we'll iterate. Let us take this n as start time dot size. So we'll start iterating and index will go up to n and we'll say index plus plus. And now we have to populate this jobs array. So we'll say pushback start time of index, end time of index, and the profit at the current index, right? Now, after populating this, we are going to sort this jobs array. And we are also going to sort the start time array. Fine. And we'll say that return, let's create a function. Let's create a function as max profit. So it will be returning us the max profit. And let's say we are going to return the max profit. And what are we going to pass? We are going to pass the current index. So we'll be starting from 0, which will be our current index. We'll be passing jobs array and we'll be passing the start time array. Now, why are we going to pass this start time array? The reason being, we are, as mentioned here, that we need to find this next index, right? And we are finding that next index by applying that lower bound method to this next time array. So here we are going to write current index vector of vector int jobs and start time. Okay. So what will be our base case? So our base case would be that I have completely exhausted my array. Let's say I have taken job 1, I have taken job 2, job 3, job 4, and I have reached this endpoint. So that would be our base case. So if current index becomes equal to jobs.size, then what are we going to return? We are going to return 0. Why? Because since we have completely exhausted the array, so we don't have any more jobs left, so we are not going to make any profit. Now after that, we are going to make a take call and a not take call, and at last we are going to return the max of the take and the not take, right? So what are we going to do in the take call? In the take call, we are going to add the profit. Why? Because we have, we are going to add the profit because we have taken the current job. So we'll say that jobs of current index give me its profit, and we are going to make the recursive call to move to the next index. And this will remain as jobs and this will remain as start time. Okay, so we are going to find this next index in a couple of minutes. And what we'll do in the not take call? In the not take call, in the not take call, since we are not taking this job, so we won't get any profit. So we'll simply move to the next index. So we'll say that current index plus 1 jobs start time. Okay. Now let's find this next index. So this next index would be lower bound start time dot begin start time dot end. And whose next do we want to find? What this lower bound does, it gives us the just greater value to whatever value we mention here as the third parameter. So since we are going to take the current job, so our next job which we are going to take, it should start at a time which is equal to the end time of the current job, or which is greater than the current, end time of the current job. So we are going to write that jobs. So we are going to write that it should be either equal to the end time of the current job, or it should be greater than the end time of the current job. Okay. Now this returns us an iterator, and in order to get an index, we are going to do start time dot begin. We are going to subtract it from here in order to get the index. So this is the complete code. Let's run this on the given test cases. So we are getting a correct answer. Now, once you'll make a recursive tree for this problem, then you'll find that there are multiple overlapping subproblems. So whenever we have a multiple overlapping subproblem, we can make use of memoization. So I'll be using a vector int memo over here. Now you may ask why I have used a 1D array, right? The reason being there is only one parameter which is changing, and that's current index. And the maximum value that this current index can take is the length of the array. So I'm going to initialize this memo of size n, and initially it will have all the values as -1. And I'm going to pass it over here, memo, and over here as well, vector in memo. Let's add it in the recursive calls, memo. Now, before making these two recursive call, we will check that if we have already found out the value present at current index, it means that it is not equal to -1. So simply we'll return the value present at the current index, and we won't make these two recursive call. Otherwise, we'll make those recursive call. Now let's also store this value in the now let's also store this value, and we'll return memo of current index. Sorry, index. Yeah. So let's run this on the given test cases. So it's working fine. Let's submit it. So it got accepted. Talking about the time complexity and the space complexity. So the time complexity will be order of n log n. Why? Because we are here, you can see that we are completely traversing over the entire jobs array, which will take us order of n time complexity. And additionally, here we are finding this lower bound, right? And it makes use of binary search for this, which is going to cost us order of log n time complexity. So after multiplying that, we will be getting order of n log n. And talking about space complexity, it would be order of n, because we are using this vector to store the values which we have already calculated. So that's all about today's LeetCode challenge. Thank you.